Hello, my name is Joe Stone and I'm an engineer for TSI Instruments, High Wycombe. Today I'm going to talk you through the setup of our positive and negative ductwork accreditation system called the PANDA. This system is available in 230 and 110 volt versions. It also can be bought with and without the instrumentation. A brief overview of the unit is that it's a large fan for pressurising the duct and a fan controller for controlling the fan. There is a measuring section which has a flow grid inside, which is a very accurate device for measuring the flow or the leakage rate that the pan will do. All of this is mounted in a mobile frame which makes it easy for transportation. Now I'm going to unpack the instrument box and explain the contents. Firstly, we have the instrument manual, obviously a very important thing, it covers everything you need to do. Inside you'll find your certificate of flow verification. That's also quite important. This is your duct adapter. You'll fit this to the duct under test. Your flexible duct fits this end. There are some clamps in the box that you can clamp around it, and there's a tapping there if you want to use it to measure the static pressure in your duct under test. This device is a low flow nozzle. The PANDA, as it stands, is capable of measuring 10 to 200 litres per second. If you need to go below 10, you can use this device to get from 10 down to 1 litre per second. It simply clamps onto the end here, and you use the PANDA as you would normally. Provided with 5 metres of flexible tubing. This is so you can measure the static pressure from your duct under test and connect it back to the instruments. There's another pack with some red and blue tubing. This is so that you can connect your TA465P to the flow grid to measure the flow or the leakage rate. There are also some adapters in here which allow you to adapt this tubing nicely onto the instruments that you're going to use. 2 clamps, that's to clamp your flexible duct to the duct adapters. And there's a thermocouple, which is to use to measure the ambient temperature in the test duct. This plugs into the TA465. You can also use it to measure the ambient temperature in your duct under test. Two instruments. This is your TA465P, and this is the PDM610. This is meant using the leakage rate, and this is to set up the static pressure. When they arrive, they come in their own cases. You can use the cases if you like, or there are positions available in the box to protect them if you so. Lastly, you have a 230 volt mains supply adapter. You can also get a 110 volt version, but that's a separate PANDA with a yellow socket. You cannot use one or the other, you can only use the 230 or the 110. And it must be wired up by a qualified electrician. And that's the contents of your instrument box. To reduce the weight of the PANDA, you can actually remove the instrument box, and you can also unclip the flexible tubing duct and remove that as well, which makes the PANDA very mobile and easy to use. Okay, so now what I'm going to do is show you how to connect the PANDA up for a leakage test. We already have flexible ducting connected to the flange here. As you can see, we've already used a strap to make sure there's no leakage from that, and we do recommend that you use these straps when carrying out your tests. When using the flexible duct, please make sure that they're as straight and as least bends in as possible. The other end, of course, is already connected to the ductwork under test. If you need to carry out a negative test, you can connect this flange to the other end of the PANDA. In this case, we're carrying out a positive test, so we're going to connect it to the fan outlet. Like thus. And of course, don't forget to connect the plug to the socket on the end of the PANDA for your power supply. Okay, as you can see, I've already unpacked the instruments and the tubing from the instrument box. I already have the static pressure is already connected to the ductwork under test, and we're going to connect that to the PDM610. Now, before you connect any of the instruments, you do have to make sure that they've been zeroed first. Both these instruments are already zeroed. To make the connection easier, we apply these tube adapters for each of the tubes. So you can actually push this tube on here, like easily. And this tube will go to the positive connection on the PVM610 to measure your static reading. So just do that. Now, for the TA465, we're going to actually measure the readings from the flow grid. It's important you get these tubes around the right way. Red for positive, blue for negative. They're clearly labelled on the side here, so just put the red onto the positive, blue onto the negative, and the same applies when we connect them back here. Red to the positive connector, and blue to the negative connector. So they're both connected to the TA465P. And lastly, what we need to do is just push the thermocouple connector into the test duct so that we can measure the temperature under test. This K-type connector just pushes into the bottom of the socket on the TA465 there. And now they're ready to start the test. We now have everything connected up and ready for the test. We just need to set the instruments up ready. PVM610 has already been zeroed. Just make sure that you have the right unit selected, obviously pascals or inches water gauge. In this case we're going to use pascals, and that's what it's already been set up for. And then the TA465, well, we now have to set up the leakage application. So basically we go into the menu, go down to application using the arrow keys, press the center return key, and we're in the applications menu. The bottom application is the one we want, which is the leakage test application. So select return. There are two options here. There's the EN standard and the SMA CNA, which is the American one. In this case we want to carry out the European test, so we just select that one. And we're now in the main menu, which is the leakage test. Now all the options in here we need to make sure are set up correctly, and I recommend the best way to do it is to work from the top to the bottom. The surface area is the surface area of the ductwork system that you're about to test. Please don't get this confused with the cross-sectional area of a duct. It is actually the surface area of the outside of the duct. So you need to have that value measured and ready for when you do the test. In this case we're going to assume that it's 10 metres squared, but you can actually change that by using the arrow keys, as you can see in this case. And you have the right arrow to turn, and that saves that value. Move down to the next option, which is static pressure. Now static pressure is the pressure that you're going to maintain the ductwork system at while you're carrying out the test. You'll monitor the static pressure actually on the PVM610. Most of the standards recommend as the starting point about 400 pascals, but your specifier may or should actually give you a value to use for this. So we're assuming 400 pascals. Again, you can use the arrow keys to change it. When you're happy with that value, just press return. Flow device. There are two flow devices to the Panda. There's the built-in flow grid, which is what we should be using, but as you can see there's also the low flow nozzle, which is just named the nozzle on here. If you wanted to use the nozzle you just select it, but actually you want the flow grid in this case. Then we have the tightness class. Tightness class is specified by the standard. There are 4 tightness classes, A to D. A to C are the ones we'd normally use. D is used for special laboratory purposes. A is the easiest one and is the least tight of the classes, and which we will use today. So we would go in there, select the option you want, A in this case, save it, that's there. Now we now need to set up the test length. Now the test length, the standard specifies that the test length should be at least 5 minutes. So we're actually going to change this to read 5 minutes. There we go, 5, save that. And then we've now got all the parameters that we require for the test set up and ready to go. So we can now go to the run screen, which is actually called run test on here. Go into the run test. Don't worry, because the test is not running, although it is active. You can actually see the leakage factors, the leak limits, leak rate, etc. as they are, but they aren't being logged for the test yet. When you're ready to start the test, you hit the start button. This screen is very useful because it allows you to make sure that you're getting stable readings before you actually start doing the test. So that's where we are at the moment. Okay, we now have everything ready and set up for the test. So to begin the test, what you need to do is set up your test duct to 400 pascals, or the value that's been specified. So we will now set up, so turn on the fan speed controller, turn it to the run position, and then wind it up. Watch the PVM610 and watch the values come up. As you get to near your position, you'll probably need to slow down. It can take some time to get a stable reading. Once you have a stable reading, i.e. it's reading your 400 pascals or whatever value you've chosen, when you're happy with that, we can then move over onto the TA465. Now we've already got this one in the leakage test screen, so it's actually reading flow values, but it's not actually doing the logging at the moment. From this screen, it's quite important, the important values are the leak factor and the leak limit. The leak limit is what the standards specify that you mustn't leak greater than. So when you get the leak factor, if it goes higher than the leak limit, then it's going to fail. This is now going to run for 5 minutes, so we're going to start it. So it's now testing. Now these values will pass, this is good. I can see they're below the leak limit. At the end of the test, we'll get a pass or fail. Hopefully, in most cases, it's a pass. If you get X's up instead of the values for the leak factor and leak rate, then basically it's gone under range. That doesn't mean your test has failed, it just means that the leakage rate is actually lower than the PANDA can measure using the flow grid. You need to then use the low flow nozzle and switch over to that and use that to measure the lower flows. Everything else is on the screen and is as you would need it. Once it's finished, you can save the data and load it into a spreadsheet and manipulate it from there. And really, any other details you need are available in the manual, or you can get them from our website, which is www.tsi.com. And thank you for your attention.